Now, having looked at the explanation for how we would add fractions and how we would use common fractions or common denominators in the previous example to add fractions. Now let's see if we can come up with a really crisp explanation of when we should be adding the fractions. Now remember it before we emphasized no key terms. There's something more than relying on key terms in order to, when we are trying to make sense of problems, and especially when we're trying to make sense of problems containing fractions, involving fractions. So let's see if we can make sense of whether each of these cases, 6 questions, is a example of a half plus a third. So what we really need to do is try to make sense of the problem and see if it makes sense to solve it by adding a half and a third. So what we need to do is make sure that we're looking at the meaning of the half and the meaning of the third, and to see if if adding those two fractions, two amounts, would make sense and would get our result. So Tom pours half a cup of water, into an empty bowl, and then pours a third of a cup of water into that bowl. So we have a cup of water, and Tom is going to pour a half a cup of water and a third cup of water into the bowl. Does it make sense to say a half plus a third here? And we know that from our exploration before, we knew that was 5, 6. But does it make sense to add a half and a third here? How many cups of water are in the bowl now? Well, it does make sense because we're pouring half a cup of water and a third of a cup of water. Our whole is a cup of water for both of those fractions. And in order to figure out what the total is, so we're adding to, or we're putting together, depending on how you're looking at the problem. So it makes sense that we're going to be looking for the sum. So here it is half plus a third. Now let's look at the next question. Tom pours a half a cup of water into an empty bowl and then pours in another 1/3. So we have a half a cup of water. So this is cup of water. And he pours in a cup of water, but then he pours in a third. A third what? Is it a third of a cup of water? If that's the case, then we're back to question 1. But we don't know what the whole is here. So if we don't know what the whole is, there's no way we can solve this problem. We don't know if this is going to be a half plus a third. There's no way we can tell. All right, number 3 and 4. Now these are tongue twisters, so let's see how we do. Half of the land in the heel-toe county is covered with forest. A third of the land in the adjacent toe-joint county is covered with forest. What fraction of the land in the two-county heel-toe joint region is covered with forest? So we have half of the land in the heel-toe county and a third of the land in the toe-joint county. So let's draw this without making any assumptions that we're not told about. So this is going to be the heel-toe county, and I've got the, let's say, toe-joint county. Okay, half of the land of the heel-toe county, and a third of the land of the toe-joint county, are covered with forest. Does it make sense to add 1/2 of the heel toe and a third of the toe joint? And does it make sense to say that that's a half plus a third? That's 5, 6. Well, let's see if we can make sense of it. Let's see if we can estimate it. Half of the heel toe county and a third of the toe joint county. Is that 5/6 of the combined area. Almost all of the combined area? No, that doesn't make sense. It doesn't make sense because it's less than half of the combined area, not 5/6 of the combined area. So this does not make sense, is not a half plus a third. Why not? Well, why not is that we have a different whole. So in fact, we have a different whole between, so the whole for first addend does not equal the whole for the second addend and does not equal the whole for the sum. We have different wholes. Now for the if we go back and just make sure that we can clarify what's happening in 1 and 2. In 1, we have the whole for the first addend was half a cup of water was equal to the whole for the second addend was equal to the whole for the sum. It was in cups of water, and cups of water. So that in number 1 was fine. In number 2, we had the whole for the first addend was not necessarily equal to the whole for the second addend. So that was not going to be an example of adding those fractions. Adding fractions with different wholes. So let's try number 4. So number 3, all the wholes were different. How about number 4? Half of the land in the heel-toe counties covered with forest. A third of the land in the toe-joint counties covered in forest. They have the same land area. Interesting. So, and then we need to know what fraction of the land in the 2-county heel-toe-toe-joint region is covered with forest. Okay, so these are adjacent, and they're actually same area. And this is heel-toe and toe-joint. Let's see if we can shade the forest here. Half of the heel-toe and a third of the toe-joint. Now, we know that whole for the first addend, the heel-toe county, is equal to the whole for the second addend, the toe-joint county. But what is it asking? It's saying what fraction of the land in the 2-county heel-toe-toe-joint is covered with forest. So of this region, of this whole, how much is covered with forest? Is it 5/6? And again, it's less than half. So it is not the same as the whole for the sum that they're asking for. So they've switched the whole. Notice the land of the heel-toe county versus the land in the toe-joint county, and then the land in the 2-county heel-toe-toe-joint region. So this is not half plus a third. We can figure that out. We can figure out what that amount is, but it's certainly not just a half plus a third. All right, so we know that this, in summary here from these 4, the first 4 questions, is that the wholes of all of the addends and the sum have to be the same. So this, in order to be able to add our fractions, the wholes have to be the same. Whole for first addend must equal the whole for the second addend, must equal the whole for the sum. Now let's look at questions 5 and 6. Students at Martin Luther King Elementary School could vote for all the lunch choices they like. Half the children say they like to have pizza for lunch, and a third of the children say they like to have a hamburger for lunch. What fraction of the children at Martin Luther King Elementary School would like to have either pizza or a hamburger? So they could vote for all lunch choices they like. So let's see as what happens. So we have the children of the MLK Elementary School like pizza, and a third of the children like hamburger. Sounds like sounds like the whole for the first addend is equal to the whole for the second addend, doesn't it? And then it says, what fraction of the children at MLK elementary school would like to have pizza? It sounds like that's also the same as the whole for the sum. So it seems like that's okay. But does it make sense that half plus a third, so this is the hamburger, and this is the hot dog. Oh, sorry, this is pizza, and this is hamburger, that we will have 5/6 of the students liking pizza or hamburger. Well, what happens if we have students 1, student 2, student 3, and student 4? And student 5 and student 6. So pizza and hamburger, pizza and hamburger. Now, student 1 voted for pizza, and student 5 voted for pizza, and student 3 voted for pizza. So we have 1/2 of the students voting for pizza. And we need 1/3 of the students voting for hamburger. And let's say student 2 voted for hamburger and student 5 voted for hamburger. So how many students voted for pizza or hamburger? So 1, 2, 3, and 5. So we had 4 out of the 6 students voting for pizza or hamburger. But this would have given us 5 of the 6. So what went wrong? Pause the video and think about what went wrong. Well, what went wrong was this student who voted for both. So we have an overlap of sets. So we don't have a length plus a length. We have an overlapping bit of fractions. There are some students that voted for both. So this is not going to be a half plus a third. So let's see the last one. So in addition to having the wholes for the first addend, second addend, and the sum being the same, we also need to make sure that our sets are not overlapping. All right, so half of the children in Timothy Elementary School like pizza for lunch, and the other half does not like pizza. Of the children who do not like pizza, have pizza for lunch, 1/3 like to have hamburger. What fraction of the children? So let's draw this out. This is the Timothy Elementary School kids, all in here. Half of them like pizza. Now, of the kids who do not like pizza, so of the kids on the right, 1/3 of them like hamburger. Is this 1/2 plus 1/3? Well, what's the whole for addend 1 for pizza? Well, that's the Timothy Elementary School children. What's the whole for 1/3? Well, that's the 1/3 of the kids in Timothy Elementary School who don't like pizza. So these two are not the same. So this is not addition of 1/2 plus 1/3 because our fractions do not have the same whole.